Picture is clear. And boom!
Boom!
All right, Tech Town Season 3, Episode 1. We're coming at you live!
Season 3!
We're here!
That's
We're coming to get you. We had a nice break. You know, this is our town wizard.
Hello, Roy.
I'm Mr. Ellsberg. We're going to bring you all things tech.
That's right. This is Tech Town. I don't know if you're familiar with Tech Town out there. For those of you who aren't, we tell you everything you need to know.
That's right. You don't need to think for yourself.
No.
No, we're here to do that for you. Thinking is hard.
Yeah. And mostly about tech, but really in general, too.
Yeah, we're here coming here with life advice, you know, and all of those things. And we're just going to, you know, go ahead and paint a picture for which you can live inside of the drawing picture. You know what I mean?
Wow, yeah, that's exactly what I want to do.
Yeah. So we are going to talk all things tech. And today we're talking about how the internet twerks.
How the internet twerks. Yeah. Yeah, it's been doing a lot with its booty lately. So here's the thing. The internet, it's kind of amazing, right? We all are using it all the time, and it's doing its thing. But it's so much more amazing than everybody realizes. Like, if even you're just visiting a website, that is amazing. Or what's happening now with this, you know, live hangout, that's amazing on YouTube. So I got to explain it a little bit.
It's a bit of magic.
It is a fair bit of magic, and it's also super understandable if you kind of like look at each little piece.
Peel back the curtains.
Exactly, peel back the curtains. I am a curtain peeler.
All right, Mr. Copperfield. Show me your secrets.
So first, let's get in the zone, right?
Yeah.
So Google announced that they're making a home Wi-Fi router.
Okay.
I don't know if you heard about this. It wasn't that big. I don't know. I mean, it's sort of out there, but
I heard a little bit. It's the little, like,
yeah,
you know,
a little thing,
cylinder thing.
Didn't have a press conference or anything. It's just like, all right, we're making it. Okay, so check it out. Google's it's called OnHub.
And you talking about Google or Alphabet?
Well, this this I believe is Google,
okay.
But we'll talk about Alphabet another day. So Google is doing the home Wi-Fi game. They've gotten into the cell phone service game. They've gotten into the home internet game with Google Fiber. And so what they're doing now is they're getting into the home router game.
Right.
And so check it out. This is OnHub, and it's just a home router. It looks like this little cylinder, but it's the thing that will take your internet you get from Comcast or CenturyLink or whoever you get your internet from, and it'll give you the Wi-Fi for your house. And
okay, so
it's having a couple features, you know, it's pretty sleek. It'll run network checks. You know how routers these days won't really tell you what's wrong? It's just like doesn't work, or some lights are flashing or something.
Right.
So this will actually theoretically tell you what's wrong. It's faster. It kind of does certain things. It's a little more secure, maybe. That has yet to be seen, actually. I'm kind of curious about that. So, okay, cool. They're making a router. It's $200. All right. But the point is, routers are just the beginning.
Just the beginning. Well, I mean, yeah. I mean, how does it get to the router?
Exactly,
like,
right? So Google's in on basically every little part of this too, which I think is interesting. So as we explain how the internet goes, think how Google's on every single part of it. So first, with these routers, that's your house entryway to the internet, is your home router. And so you have the internet coming from Comcast, let's say, and then you have your different devices in your house connected to that router, and each one is saying what they want and hoping it all goes right. So let's say you're on your phone, I'm on my computer, someone else is watching Netflix. All those things are coming from their different devices. They're going out into the wild world of the internet, doing their thing, and then coming back, hopefully, to the right device. Okay. Because what if the Netflix accidentally came to my phone where I was trying to check my bank, and you know, your YouTube animal karate videos accidentally came to the other person who was trying to check their email?
There you go.
You got to know how to route these things.
Someone's gonna get karate chopped, you know, and then you're gonna see a movie on you know, On Point Credit Union.
Right, which, you know, could be worse. But okay, so this is the idea. So it starts with your computer and your cell phone, whatever, goes to this router. Okay. Then that router is connected to a modem or some way of getting to the Comcast. Yep. They have a bunch of routers that are routing everything everywhere, and then those route to web servers. So I wanted to show you a little bit of a diagram to go along with this, because it's hard to talk about without diagrams. I do want to also enact it. I want to live
diagramma.
A diagramma. That's right. I remember making those. All right. So this, by the way, I have a link to in the show notes, which is below the
Yep. Just remember,
video.
you just have to scroll down below on our YouTube page, and you'll see all of our show notes right there.
Yeah. So we've got the link to this paper on how the internet works. And it's basically pretty long, but overall
it looks like it's black
short.
and white.
It's very black and white. It's very black and white. It says how it is. But I think it has a couple of these good diagrammas.
Yeah.
And here's like a good one to kind of like take some time to read about.
Right.
So you have different layers on top of this one wire. The internet really is a wire. That's the way to think about the internet. All it is a wire.
Okay.
And it's connecting a bunch of computers. Sometimes that wire is like a satellite, so it's like wireless wire. But it's just this wire, and then you got a bunch of computers. But to get stuff over that wire, people wrote a bunch of code to sort of do things on top of previous things.
Okay.
So first, just to get a 1 or a 0 across the wire, just, a 1 or a 0.
Yeah.
You got to get the 1 or a 0. And then once you get the 1 kind of fitting in, the 0 is a little fatter, so you got to have bigger pipes to get the 0 through. So then you get the 0 through, and so, okay, you can get some 1s and 0s, but what you really want is you want consistency.
Right.
So if I sent a 1 or a 0, I want to know that you got it.
Okay.
Not just like send it out blindly and then say, I hope you got it.
Yeah.
So we come up with a couple concepts. First of all, an address. So every device has an address called an IP address.
Okay.
You may have heard this or seen like, what's your IP address?
We've talked about it before.
Exactly. So hopefully you experts know now. It's the address of your device.
Yep.
And that's how you send a message to somebody else.
Okay.
So that was pretty good. We've got addresses now. But how do I know that you got my message?
Right.
And how do you know that my message is the message I sent, not somebody sneaky in the middle that intercepted my message and changed it up and sent it to you? So then you start building code to do all these things on top of it. So when you see all these layers, that's what it is. It's kind of like a history, really. They started with this thing just to send any 1s and 0s. They realized, okay, we got to do a little better than that. So they added a few things on top. So now there's these layers. And sometimes it goes really all the way up to a website. A website's kind of the highest layer. Right. It's just the final thing that kind of comes across. But what's happening is that website's being broken down, sometimes packaged up, compressed. It's smaller to fit across these wires and go faster. And then making sure it's the right one, not the wrong one, that it's from the real person, all that stuff. Now, how does it go from this address to this address? So there's these routers, right? So we have our home router, but imagine those times a big amount.
Okay.
So they're beefy routers, one per maybe, I don't know, let's say every 100,000 routers that we would have in our house that are out. You can imagine just out in the street.
Just giant routers.
Basically underground or wherever they are.
Mega routers.
Yeah, you can even see a little building sometimes. They say that it's like a Comcast big router. And so what they're doing is they're taking all the people's individual house things that they're asking for, and this means websites, it means Netflix videos, and not even the whole video, just like what they need at that moment, just a little part of a video or a part of a file. It's all these, they call them packets, right? Packets of information that are all zipping around, and there's a bunch of packets that make up any single video or any single even word. There's packets, and so it's routing all these packets. So imagine I'm a router, a big router, right?
Okay, mega router.
And you're a packet.
Mega router, Wizard Town.
Yeah, that's my name. Happy to help.
And I'm a packet.
You're a packet. All right. So your destination is google.com. You want to tell google.com, hey, give me some information. Fill my basket with your Googles. So
I'm going through. I take a little bit of this, little Google.
Now here, I'm the traffic cop.
All right.
Or no, that traffic cop's lame. I'm going to be a helpful tourist guide.
Okay.
All right.
Tourist guide.
Now, the only thing is, I only know my area. I don't really know all the way to Google's area. That's like another part of town. I only really know my couple blocks, but I also know the general direction of where Google's at.
Okay.
I don't know exactly, but I'll at least get you closer. I promise. So, hey, Packet Man, you come. What's your destination?
I'm going to Facebook.
Going to Facebook. Oh, okay. So here's what I do. I look up in my database. Each router has like their little list. I got my list, my checklist. And I look you up and I say, oh, okay, you're looking for Facebook. Do I know where Facebook is? I know where, let's see, I know where Yahoo is. I know where MSN is. I know where a couple of these guys in my neighborhood are, but I don't know where Facebook is. But I know that guy, that tourist guide, he knows where Facebook is.
Okay.
So his name is Todd.
Okay.
So you go find Todd.
All right, I could meet up with Todd.
Todd.0.1.92.5, specific name Todd.
Right.
A real address for Todd.
Yeah, very IP.
Go talk to him. Okay.
Todd IP.
Thank you very much.
All right.
Okay, now I'm Todd, right?
Okay.
So you're Packet, right?
Yep. Hey.
Hey,
Todd.
Hey, what's up? I'm Todd.
Todd
I'm happy to help you.
0.10500150.
That's me.
Todd.
And
Todd.
you are a Packet.
I'm a Packet.
What are you looking for?
I'm looking for Facebook.
You're looking for Facebook. Oh, I know exactly where Facebook is. Facebook is right here.
Oh.
Okay. So now you go to
Sorry,
Facebook.
Todd, I'm an idiot. I didn't see it.
No, it's okay. That's why I'm here.
Okay, good.
No worries.
All right, I'm going to go to Facebook.
So you go to Facebook, and so then what happens is you get to Facebook, and that's a real computer.
Yep.
Not just a router. You got a real computer.
Mm-hmm.
And so you open your basket, and you say, fill it.
Fill it up.
And so they know your address, too, because you all along had a name tag on that said where you're coming from, your IP address.
Yeah, Facebook knows me.
So Facebook does know you.
Yep.
Absolutely. They know your address because they need to send their information back to you. So Facebook, they don't know actually, the best way to get to your address.
Right.
So they come back to Todd, and Facebook says, "Hey Todd, I filled Mr. Ellsberg's basket with all this great Facebook information, just a bunch of packets, and this is actually happening a zillion times in like a minute, so it's not just one, it's a bunch. But still, okay. So Todd, direct my packet back to Mr. Ellsberg's computer." And then Todd goes back to router number 1 guy, tourist guy,
packet.
And he's like, "Oh, I don't know exactly where it is, but I'll help you." And these hops sometimes get to be 3, 4 hops, 5 hops, meaning 5 different tour guides, routers, that all don't know exactly where to go, but know, hey, you got to go talk to my friend over here.
Right.
And that actually happens all around the world.
Wow.
Making sure everything gets in the right place.
Skipping all over the place.
Oh, yeah.
This Chris was his giant web of connections.
Exactly. And then knowing where people need what.
With directions.
Right, directions. That's the thing. It's not just this web sitting there. It's this web that's active. Right. And now, here's a weird way to kind of break it all in your mind.
Okay.
What if Google changes their address? Or what if a new website wants to exist and a new address wants to happen? So it gets crazy, and there's a lot of things. But bottom line is, that's why these routers need to be constantly updating their little memory. Right. They've got their list, their checklist. They start passing information around. They say, "Oh, did you hear? Facebook moved." And he's like, "Oh, really?" And if enough of them confirm it, then like, "Okay, I believe it. Facebook moved," and they all change it.
Wow. So they almost learn on the job. I mean, they're doing things.
They got it. Exactly.
Now, is that something that is there a program that they have themselves that they can do on their own? Are they programmed to do that? Or does, a town wizard have to go in there and program? Or does the town wizard just go to check to make sure that the program went along correctly, or what? I mean, tell me, how does this work?
It's a mix of all of those. So it's interesting because part of it is human, because when a new device or website needs to exist, humans do put it into a system somewhere. Right. And that can go wrong. They can make mistakes, or they didn't do it, or it takes a long time. They're humans. Right. And they cause problems.
They're robots.
No, they would do it. Well, I was going to say they would do it perfectly, but here's the problem. See, robots, they can trick. Well, that's humans. True, but they'll be better than humans. So these robots get the human information. Yep. But then pass the message around like I was talking about. Yeah. But sometimes that message passing can happen like on accident, or the wrong one, or there's a bug or something, and things can get way wrong. So imagine I was wrong about where Facebook was,
but
and I start telling everybody,
people that were also wrong,
and we're all like, okay, we're all wrong, but we don't know. It's fine. So they've had examples of where like websites like Twitter just go to the wrong place. Whoa. And they'll just flood some guy in China's house, his computer, with thinking that it's thinking it's Twitter.
Oh, no.
So it's a little bit of madness too. It's a little kind of scary how it could just happen. Now there is code running on these routers, and that code is written by Cisco and written by other companies, and some of it's open source, some of it's not. But they all sort of just promise to do this routing. And if they can agree at least enough upon how to do like that, then they can write their own little code to make it do it. But it's pretty much madness. Just imagine at all times, all these packets. Wow. Hey, where do I go? Over there? Okay, we'll try it. Maybe I'm wrong. Let's try it again. Woo!
Do you know? I don't. My friend does. I don't know, but my friend might know.
My friend might know.
Like,
go talk to him.
Yeah, of course. It's over there. Yeah. Wait, where did he go? We need to find him. Let's get back to his
Exactly.
I mean, that's just craziness.
And one thing that's really fun is that if you want, It's really fun. I'm sure you think so. You go under the command line.
Yeah,
So open,
okay,
open up the command line where you can type in the commands,
Yep.
and you can do a trace route, and a trace route will show you the hops that it takes.
Wow.
It'll tell you it took 192 milliseconds total. 10 milliseconds was spent getting to the first guy, and here's his name, the router, the helper guy. Then it took 15 milliseconds to get to the next guy, and here's
his IP address.
IP address, exactly.
Yeah.
And then it's hopping around. Okay, and then it took this long to get to Google.
Crazy.
Yeah, you can see it happen.
Wow, man. How about that? Well, that is the internet in a giant nutshell.
Yeah,
well,
I would say like probably like
medium-sized.
a medium-sized shell.
Yeah, like a walnut.
A walnut shell. That's a pretty big
Yeah.
shell. Yeah. Nice. All right.
That's
that. So it brings us to the music segment of the week. That's right. Music is the thing. Music. All right. So now this week's music side of the week is if you've ever wanted to know where a band name came from, this has just a list of all of them.
Whoa,
so it's
crazy.
bittersweetband.com / some other stuff or whatever. But I've got the URL in the show notes, so check that out.
Yeah.
So let's try it. Name a band.
Let's go with Pearl Jam.
Oh, nice. All right. So P, we've got Pearl Jam. Eddie Vedder says the name is in reference to the pearl itself and the natural process from which a pearl comes from. Basically taking excrement or waste and turning it into something beautiful.
Oh, nice.
And Jam came later after seeing Neil Young play Nassau Coliseum. He played like 9 songs over 3 hours. Every song was like a 15 or 20-minute jam. Nice. All right. Or at least that's how I remember it.
The name. Or at least that's how I remember it. Boom.
Yeah. Oh, man. So, and then they've got them all. I mean, they've got Pink Floyd. They've got Fish. They've got Power Station, whoever that is. So, I don't know. Check it out. It's kind of interesting. Some of them have some cool stories behind their names.
Good stuff.
Oh, yeah.
Which brings us to
Mr. Ellsberg's Site of the Week. Site of the Week.
Site week. All right. Well, this one, I got a doozy for you because I've heard about this place called Sonic. It's doing this new internet thing that is in a few different places. That is actually trying to give the service right.
Okay, what do you mean?
Like, they're not trying to bump up the cost on you.
What is this?
Like, okay. So, like, you know how you get your Comcast service or your Time Warner service or your Charter service or your...
That's about the only option.
You
can't even get Charter.
Well, there's, what's the little one? Cricket? I mean, is that a service? I mean, there's, some little ones here. So they're trying to do it right. They're saying it's $40 a month. They're giving it to you in place. They're going to tell you exactly how fast it will be in that place where you are. It's not here yet, but it's been tested as far as being unbreakable. So you can't get hacked.
Okay. My red flag radar goes up here, but I like the sound of it. Yeah. So, all right. So I will do some investigation and check it out. But
some major
I do really like the idea of some competition. Just get some internet, get some options.
Yep. And so now, right now, it's just in a few places, right, where like San Francisco, where they can get it.
Sweet. So $40 a month, just fast, no problems,
no fuss.
Good privacy policies. That's what we like to hear.
Boom.
All right. Sounds real good.
And customer service.
Wow.
I mean, that's the big thing. I mean, this customer service is horrible on these quasi-monopolies that we have right now, like Comcast.
How do you know they're going to have good customer service?
Well, they've got an award.
They've got an award. All right.
I checked their Yelp, and they've got
that's good.
Few 1-star reviews.
Okay. That's pretty good.
There we go. Boom.
Nice.
Which finally brings us to...
That's right. Security. Lockdown. So that's right. This is the security segment. And to catch everybody up, we always have a security segment because security is so much more important than anybody realizes.
Yep.
Nobody has good passwords and nobody knows what to do. And
well, you know how you just leave your computer and your wallet and your phone in the car and you just leave it unlocked all the time?
No, I don't.
No, you don't. But that's what people do when they're online.
Exactly.
You know, you can't just leave all that stuff out there.
No, you can't.
People are gonna get it. You know, like get it.
Exactly.
Get it, and then you'll get got, and then what? We're going to prevent that.
That's right.
One link at a time.
So today's link, a little bit of a philosophical topic, which is, can you have better security with open source software or closed source software?
Ooh.
And there are good arguments to be made on both sides, and there are really bad arguments to be made on both sides that some people make. So I'll give you a bad argument.
Yeah.
Closed source is better because people can't see how it's done, so it's harder to be able to hack.
All right. Well, that's just...
It sounds like a reasonable argument.
Right.
So let me explain why it's not a good argument. Now, closed source, a good analogy is like a safe. And so I have a link that talks about the safe analogy. I think it's really good.
Right.
A safe. If you knew how the safe works, that doesn't mean you can break into the safe.
Right.
So if you could see, and you could get all the experts in the world on safes to see how it's made and make sure it has the double steel thick walls and the barbed wire and the thing that explodes the glass and makes it never whatever, and you get all these experts to make sure that's the hardest safe to break into, just because you've read the manual on how the safe works doesn't mean you get to break into the safe.
Right.
So it's like with the closed source, just because you don't know how the safe is made, it's not like you know it. And that's an argument for open source, which is you can see how it's made and you can see that it's not bad, because if you can't see it, who knows what they're doing?
Right. Another one that you could say is, in a closed source situation, well, what if you had someone that was on the inside working? You know, there's always like that mold.
Yeah, and then you wouldn't know what they're up to.
You wouldn't know what they're up to. They could be telling everybody how to get into the safe. Oh, there's this one thing that you could always do.
Yeah.
You know, like
exactly.
How do you know? You know,
Totally
I mean,
true.
like you could create it just to bust it yourself.
Yeah.
You can say like, hey, I've got this secure thing. Get into it, and then you get everybody using it, and then you personally can just get them.
Exactly, and there have been examples of all of these things. It's true, so it does happen. So yeah, so in that way, open source seems pretty good.
Yeah.
But in the recent year, even open source has had a couple big missteps. There were some vulnerabilities like Heartbleed. These were in OpenSSL. These were in open source software. And the thing is, open source just doesn't mean it's great because you know how it works. No. It still can have problems.
Yeah, and I think another big thing is that open source is a lot of times tied to like volunteerism when it comes to online stuff. And so if you have somebody that's just doing it on their free time, right, if something big happens, well, I mean, they're not just going to be able to stop what their day job is and go try to fix it.
It's true. There isn't the phone number you call that's like totally responsible for this code. It's really a lot of times, like you say, volunteers or people who do it in their spare time. Sometimes there are people that are very much really in it and really great, but it's not like there are rules about it. It's just people do what they do. And so it's amazing what we do rely on of sort of this community effort. And so I think it's really, really important that open source software is used for security for the reason of understanding what's going on. But we just have to do a better job of maintaining it, making sure that the community has reasons and incentives to actually fix it. And then we'll actually get some good security.
Boom. That's that. And so we've got all the things tech for you today. We talked about how the internet works.
Routers, routing packets,
layers, and packets, and IP addresses, all the good stuff. Then we talked about music.
Oh yeah, band names. Figure out any band name almost.
Awesome. And then Sonic.
Oh yeah.
You know, I mean, yeah, you're gonna see the Yelp reviews.
I want to see the Yelp reviews, and I want to sign up and get cheaper internet than all these bad ones.
And then finally, you know, like, I mean, we could talk all day, and then say why it's great and say why it sucks.
For open source?
For open source and closed source.
Oh yeah, and I will talk all day.
There you go. And that's what we're probably gonna do for the rest of the night. We're gonna leave you with that. We'll see you again soon. Take care, yonder Tech Townies. Bye-bye.
Tech Town.
Bye.